Hello students, let us continue the session on trigonometry. In the previous session, we had discussed exercise 9.1 till 8th question. Let's continue with the 8th question onwards. 8th question is, a statue 1.6 meter tall stands on the top of a pedestal. From a point on the ground, the angle of elevation of top of the statue is 60 degrees. From the same point, the angle of elevation of top of the pedestal is 45 degrees. Find the height of the pedestal. Here I'll consider BC to be the pedestal. Pedestal means a stage-like thing. I'll consider AB to be the statue. The statue is given as 1.6 meters. If you consider the triangle BCD, tan of 45 degrees will be equal to BC upon CD. We know that tan 45 degrees is 1. So 1 is equal to BC by CD. This implies BC becomes equal to CD. Now let's consider the triangle ACD. In this triangle, tan of 60 degree will be equal to, the opposite side is AC upon the adjacent side is CD. Tan 60 degree is nothing but root 3. AC is the sum of BC plus AB. So BC plus AB is 1.6 meter divided by CD. Instead of CD, I'll write BC. The reason is it is from 1 and I'll consider this as 1. Now let's cross multiply. A root 3 times of BC minus BC will be equal to 1.6. So BC, when you take common, we get root 3 minus 1 equal to 1.6. Therefore, BC will be 1.6 upon a root 3 minus 1. If you want, you can rationalize the denominator. Upon rationalizing the denominator, it becomes 1.6 multiplied to root 3 plus 1 divided by root 3 square minus 1 square, nothing but 2. It is same as, the length of BC will be same as 0.8 times root 3 plus 1 meters. This is the length of BC, which is the height of the pedestal. Question 9. The angle of elevation of top of the building from the foot of the tower is 30 degrees and the angle of elevation of top of the tower from the foot of the building is 60 degrees. If the tower is 50 meter high, find the height of the building. In this question, I have considered CD to be the tower, which is 50 meter high, and AB to be the building. From the foot of the building, the angle of elevation of the tower is 60 degree. From the foot of the tower, the angle of elevation of a building is 30 degree. So here we have got two triangles. In triangle CDB, we have tan of 60 degree equal to CD upon BD. Tan 60 degree is nothing but root 3. CD is 50 upon BD. We can find the length of BD to be 50 upon root 3. Now consider the triangle ABD. In this triangle ABD, we have tan 30 degree equal to AB upon BD. Tan 30 degree is nothing but 1 upon root 3, which is equal to AB upon, I'll write this as 50 by root 3, because we have got the length of BD as 50 by root 3. Therefore, I'll find out AB as 50 divided by root 3 into 1 upon root 3. We get as 50 by 3. 16 times is 48. So 2 remains. So 16 2 by 3 meters will be the height of the building. Question number 10. Two poles of equal heights are standing opposite each other on either side of the road, which is 80 meter wide. From a point between them on the road, the angle of elevation of top of the poles are 60 degrees and 30 degrees respectively. Find the height of the poles and the distance of the point from the poles. Here I have taken AB and CD to be the poles which are of equal height, and BD is the distance between these two poles. I have taken AB and CD are poles of equal heights. The distance between the poles is 80 meter. I have taken O to be the point. Let O be a point between AB and CD on BD. From here, the angle of elevation of top of one of the pole is 60 degree, another pole is 30 degree. We need to find out BO and DO. BO we need to find, DO we need to find, and also the height of the poles AB equal to CD equal to we need to find. Look at the triangle ABO. In this triangle, tan of 60 degree is AB upon BO. Let me take AB equal to CD equal to X. So root 3 is equal to X upon BO. We get BO to be X by root 3. Now let me consider another triangle, triangle CDO. Tan of 30 degrees is CD upon DO. Tan 30 degrees is 1 upon root 3. This is equal to CD, I have taken as X, divided by DO. So we can find the length of DO to be X times of root 3. We are given the length of BD. BD is nothing but BO plus OD. BD is 80 meters. This is equal to BO, which is X by root 3, plus it is X root 3. DO is X root 3. There is X common here. We get 1 by root 3 plus root 3. So X will be equal to 80 divided by 1 by root 3 plus root 3. Let us take the LCM. Here LCM is root 3, so it becomes 80 root 3 divided by 1 plus 3. So we get as 20 times root 3. X value is 20 times root 3, so we can find the value of BO. BO will become equal to x upon root 3. X value we found as 20 root 3 divided by root 3. It becomes 20 meters, and the remaining OD will be 60 meters. Let's check that also. Root 3 into x. This will be a root 3 multiplied to x value is 20 root 3. On multiplication, we get it as 60 meters. So 60 meters and 20 meters are the distances from each of the poles, and AB and BC, AB and CD, they are equal to 20 root 3 meters. Hence we have found. Next question, question number 11. The question seems to be very large. The question is, a TV tower stands vertically on a bank of a canal. From a point on the tower, on the bank directly opposite to the tower, the angle of elevation of the top of the tower is 60 degrees. From another point 20 meters away from this point, the angle of elevation of the top is 30 degrees. Find the height of the tower and width of the canal. Here, observe the figure. AB is a tower. BC is canal. There are 2 points from where the top of the tower is viewed with angle of elevations 30 degrees and 60 degrees respectively. So in triangle ABC, we have AB upon BC equal to tan of 60 degrees. The length of BC becomes equal to AB by tan 60 degree, which is root 3. Now consider the triangle ABD. In this triangle, tan of 30 degree is AB upon BD. Tan 30 degree is 1 upon root 3. This is equal to AB divided by, instead BD, I'll write BC plus CD. Now in the place of BC, I can write AB by root 3. So AB divided by AB by root 3 added to CD. Let us further simplify that. This implies 1 upon root 3 equal to a root 3 times of AB divided by AB plus a root 3 times of CD. The length of CD is known. It is 20. So let us do cross multiplication by taking this CD to be 20. We get AB plus 20 times root 3 equal to 3 times of AB. On transposing AB, we get 2 times AB equal to 20 root 3, AB equal to 10 root 3. This AB is height of the tower. Now I need to find out the length of BC, which is the width of the canal. BC becomes equal to AB by root 3. So 10 root 3 upon root 3 get cancels. 10 meter is the width of the canal and 10 Root 3 meters is the height of the tower. Question number 12. From the top of a 7-meter high building, the angle of elevation of top of the cable tower is 60 degrees and the angle of depression of its foot is 45 degrees. Determine the height of the tower. Observe here, AB is the building. AB is considered as a building in this. CD is the tower. The top of the tower is observed with an angle of elevation 60 degree and the bottom is observed with an angle of depression 45 degrees. Let me consider the triangle ABD. In this triangle, I'll consider tan of 45 degrees, which is equal to AB upon BD. You must be wondering, why did I consider this angle as 45 degree? You just observe this particular thing is the angle of elevation of the building. In one of our discussion, we had learned that the angle of elevation and angle of depression will be equal. Also, you observe these two lines, they are parallel to each other. These angles EAD and ADB, they are alternate angles, therefore I have considered as 45 degree. Tan 45 is 1, the length of AB is 7 by BD. With this, BD becomes 7 meters. Now consider the triangle ACE. In this triangle, AC is same as BD AE is same as BD. This is equal to 7 meters. Let me take tan of 60 degrees. Tan 60 degrees is the opposite side CE upon the adjacent side AE. Tan 60 is root 3. This is equal to CE upon 7. We get the length of CE to be 7 times root 3. Now consider CD. CD is the sum of CE plus ED. ED is 7. CE we have found as 7 root 3. This is equal to CD. Here 7 taken common, we get root 3 plus 1. Therefore, the height of the tower is 7 times root 3 plus 1 meters. Question 13. As observed from top of a 75-meter high lighthouse, from the sea level, the angle of depression of two ships are 30 degree and 45 degree. If one ship is exactly behind the other on the same side of the lighthouse, find the distance between the two ships. Here, AB is considered as the lighthouse. C and D are two ships. Here, one of the ship is making an angle of elevation of the top as 45 degree because they have given angle of depression of one of the ship is 45 and another ship is 30. I am taking the angle of elevation equal to angle of depression. You can observe this line and this line, they are parallel to each other, so the alternate angles are equal. In triangle ABC, we observe tan of 45 degrees is AB upon BC. Tan 45 is 1, AB is 75, so BC becomes equal to 75 meters. Now consider the triangle ABD. In this larger triangle, tan 30 degrees is equal to the opposite side AB by adjacent side BD. Tan 30 degree is 1 upon root 3. This is equal to AB upon, instead of BD, I would like to write BC plus CD. This implies 1 upon root 3 equal to AB value is 75 meters divided by BC is also 75 plus CD. Now do cross multiplication, we get 75 plus CD to be 75 root 3. Therefore, the length of CD is 75 taken common, root 3 minus 1 meters. This particular, the length CD is the distance between the two ships. So the distance between the two ships is 75 times root 3 minus 1 meters. Question number 14. One of the important question, 1.2 meter tall girl spots a balloon moving with the wind in a horizontal line at a height of 88.2 meters from the ground. The angle of elevation of the balloon from the eyes of the girl at any instant is 60 degrees. After some time, the angle of elevation reduces to 30 degrees as shown in figure 9.13. Find the distance traveled by the balloon during this interval. The angle of elevation from eye of a girl is 60 degrees. After some time, with the wind, the balloon has moved further, making the reduction in the angle of elevation to 30 degrees. The same scenario, I'll take it in a figure format. 1.2 meter here is CD, it's the height of the girl. I have taken CD to be 1.2 meter high girl. In this, EG is the distance traveled by the balloon. What is very important thing you must do here, BG is nothing but BH minus HG. BH is 88.2 meters. You need to subtract 1.2 from there. We get it as 87. This is the length of BG. It is also same as the length of AE. This is the first important thing you must do. I am going to use this. Let me consider the triangle ACE. In this triangle ACE, look at tan of 60 degree. Tan 60 degree is AE upon CE. The length of AE I have found, it is 87. The length of C, we need to find it. The tan 60 degree is root 3. So root 3 is equal to 87 upon CE. We get CE to be 87 upon root 3. Now let me consider the triangle BCG. We have got tan of 30 degrees equal to BG upon CG. Tan of 30 degrees 1 upon root 3. This is equal to the BG length is 87 divided by CG. We get CG as 87 times root 3. We have got the length of CG and CE. We can find the length of EG. EG will be equal to CG minus CE. CG is 87 root 3 minus CE is 87 divided by root 3. We can take 87 common. We get root 3 minus 1 upon root 3. What is root 3 minus 1 upon root 3? Take the LCM. It becomes 3 minus 1, which is 2, upon root 3. So 87 into 2 by root 3. I would like to multiply root 3 and divide by root 3 so that it becomes only 3. We can simplify further. 3, 2 times is 6, 2 remains, 9 times is 27. So 3 multiplied to 29 gives 87. 29 multiplied to 2 is 58. So the result is 58 root 3 meters. This question is one of the important question. Question number 15. A straight highway leads to the foot of a tower. A man standing at the top of the tower observes a car at an angle of depression 30 degrees, which is approaching the foot of the tower with a uniform speed. 6 seconds later, the angle of depression of the car is found to be 60 degrees. Find the time taken by the car to reach the foot of the tower from this point. This is also one of the very important question. Let's solve this. Look at the figure here. Here CD is representing the highway, AB represents the tower. C is the initial position of the car and D is the final position of the car after 6 seconds. Look at the angle of depression. It is 30 degree. It is same as angle of elevation if you consider C to be the point of reference. Same way, if D is the point of reference, the angle of elevation is 60 degrees. So let me mention it here. AB is representing the tower. C is initial position of car. D is position of car after 6 seconds. Look at the triangle AT. dB. In this triangle ADB, we have tan of 60 degree equal to AB upon DB. Tan of 60 degree is root 3. Root 3 is equal to AB upon DB. I can write DB to be AB by root 3. Let me name this as equation 1. Have a look at the triangle ABC, the larger triangle. In this triangle, tan of 30 degrees is AB upon CB. Tan 30 degrees is 1 upon root 3. This is equal to AB upon, instead of CB, let me write CD plus DB. We know the length of DB in terms of AB. Let me substitute that. I will be getting CD plus DB as a root 3 times AB. Now I'll write, instead of DB, AB upon root 3 equal to root 3 AB. This is from 1. From this, the length of CD becomes equal to root 3 minus 1 by root 3 times AB. I have transposed AB by root 3 to the other side. On simplification, it becomes 2 by root 3. So the length of CD is 2 by root 3 times AB. Let me name this as equation 2. The time taken to travel the distance CD is nothing but 6 seconds. Therefore, the speed is given by distance upon the time taken. Here the distance moved is 2 times AB by root 3. This is the length of CD divided by the time. Time is 6 seconds. So we get it as AB divided by 3 times root 3 meters per second. Therefore, the time taken to travel BD will be equal to distance by time taken. Here the distance is AB by root 3 divided by AB by 3 root 3. On simplification, we get it as 3 seconds. Therefore, car will take 3 seconds to reach the foot of tower. Last question, question number 16. The angle of elevation of top of tower from 2 points at distance 4 meter and 9 meter from the base of the tower in the same straight line is with it are complementary. Prove that the Height of the tower is 6 meter. I have taken the angle to be theta and the other angle becomes 90 minus theta because they are complementary angles. The distance of the points R is 4 meter and S is 9 meter respectively. Look at in triangle AQR, what is tan theta? Tan theta is AQ, the opposite side, by QR. With this, I get tan theta to be AQ by 4. Let me name this as equation 1. Look at the triangle AQS. In triangle AQS, what is tan of 90 degree minus theta? This will be equal to AQ upon QS. We all have learned the complementary relation. Tan of 90 degree minus theta is given as cot theta, cotangent theta, which is equal to AQ by 9. Let me name this as equation number 2. Let us do equation 1 into equation 2. I am multiplying them. I'll be getting AQ by 9 multiplied to AQ by 4 equal to tan theta multiplied to cot theta. These two are complementary angles, reciprocal angles. Then tan theta and cot theta multiplied, this becomes 1. So AQ square divided by 36 equal to 1. This implies AQ is plus or minus 6. Therefore, AQ should be taken as positive 6 because the negative height should not be considered for any object. So 6 meters is the height of the tower. We have proved that the height of the tower is positive 6 meters. With this question, I end today's session. We shall see the questions of NCERT exemplar in the next session. Thank you.